Can you hear me fine and see the screen?
Yeah, perfect.
Okay, thank you. As Professor Acevedo said, I'm Miguel Cánigo Iglesias. I'm a PhD student at the University of Santiago de Compostela, and I am currently also a research assistant for the FirESmart project in the Mountain Research Center of Bragança. Welcome to my talk, Coping with Fire in a Mediterranean Biosphere Reserve, a multi-objective plan under uncertain future global change. So, as you may already know, global change drivers such as climate change, land cover change, or wildfires are putting increasing pressures on biodiversity and ecosystem services, raising the need for new management policy that aims to both mitigate impacts, for example, with a climate-smart approach aimed to increasing carbon stocks to palliate climate change, or a fire-smart approach that aims to build a fire-resilient, heterogeneous landscape where fuel loads are low and disconnected. And also this new management needs to be integrative, needs to have multiple management goals that allow nature conservation to coexist with socioeconomic development. Of course, when accounting for multiple management goals, conflicts or trade-offs might appear, and they can be solved by integrating management zones where compatible goals are assessed together and incompatible ones are assessed in a different management zone. The UNESCO Biosphere Reserve have popularized a zoning scheme based on three management zones. The first is the core area, dedicated mainly to stricter conservation. The buffer zone, which mainly surrounds the core area and disconnects it from the transition areas that are dedicated to the other uses, more incompatible perhaps with conservation purposes. So we ran a case study in the Meseta Ibérica Biosphere Reserve, which is a transboundary biosphere reserve designated in 2015. It's located in the northwestern Iberian Peninsula in the border between Portugal and Spain, and has a total size over 11,000 square kilometers. It is divided in the three management zones I just mentioned. You can see them in the map. And currently it has a population of around 300,000 inhabitants and is currently facing challenges such as the population aging that are leading to high land abandonment, leading to fuel enroachment, and together with the Mediterranean climate of the region present a serious threats with wildfires. So our research followed a systematic conservation planning approach based on the spatial modeling of species distribution and supply of ecosystem services under both historical and future conditions. We use the spatial prioritization tool Martian with zones to obtain alternative distribution of the zoning under each scenario. We start our framework with initial assessment of the land cover in the year 2005, and then used a series of landscape dynamic transition matrices to build 4 alternative land cover maps representing 4 alternative landscape management scenarios, in addition to 2 climate scenarios, which were RCP 4.5 and 8.5. Here you can see an example of the land cover maps. We had an afforestation scenario marked by a forest cover increase, a business associated scenario marked by current tendencies of land abandonment with a lot of shrubland and enroached vegetation, and then 2 more fire-smart scenarios, which were fall and return, defined by the expansion of agricultural areas, and the agroforestry return with a simultaneous increase in agriculture and agroforestry. So with these land cover maps, we started modeling a series of management features. I sadly cannot get into modeling details due to time, but they were 4 ecosystem services: carbon sequestration, agricultural surface, soil erosion control, and recreation opportunity, and also the distribution of 207 species, including birds, amphibians, and reptiles. We used 2 sets of models, one modeling the climate suitability and the other modeling the habitat suitability, and we only use as actual presences the location where both models agree on a presence. So these locations would have both a habitat and a climate suitability. We gathered information on all these features along the study area and sampled them across a grid of 1 square kilometer planning units. And then we also modeled a penalty for the selection of planning units that was fire intensity. Fire intensity was divided in 5 classes, representing both the extinction difficulty and also the degree of environmental damage, assuming that higher intensity leads to higher damage. Then we specified Marchand that 3 zones should exist: the core area, the buffer zone, and the transition area, in addition to an unselected zone that is usually required for the proper functioning of Marchand. Then we also defined that the spatial arrangement of the zones should have the core area as disconnected as possible from the transition area, using the buffer zone as an envelope, similarly to how it's done in real biosphère reserves. And then we defined a series of representation targets for both species and ecosystem services. For biodiversity, we had a target of 200 occurrences, ensuring that the most rare species have their full distribution in the area covered, and the common species do not become overrepresented. Then we divided these targets across the management zones, attending both to the prevalence of the species and to their habitat. For the rare species, all the occurrences have to be secured under the core zones. And then for the most common species, for generalist and open habitat species, we allow a part of this target, 50 occurrences in the transition areas, whereas for forest and wetland species, we only split the target between the buffer and core areas. Then for ecosystem services, we calculated 70% of the amount present in the initial scenario of the year 2005, and then took this amount and transferred it as a target for the future scenarios. And as you can see here, to avoid potential conflict, we decided to allocate the largest part of the agriculture to the transition areas, whereas other services such as the carbon or erosion control were in the core areas, and recreation in the buffer areas. So to summarize this complex and long methodology, what Marchand will try to do is allocate the different planning units to one or another management zone in a way that achieves both the overall and the zone-specific targets, minimizes fire intensity, and has the core and transition areas as disconnected as possible between them. And using the new distribution of management zones under each scenario, we run a comparison both across scenarios and between the scenarios and the real zones implemented in the reserve. First of all scenarios managed to achieve the targets, both for biodiversity and ecosystem services, with the exception of some species that went locally extinct from the area due to climate change. So it was impossible to meet their targets. And to achieve these targets, each scenario required a different amount of area under each zone. We can see that for the buffer and core areas, there are not much difference, but for the transition area, there is an almost 400 planning units, that is 400 square kilometers of difference between, for example, business as usual under RCP 4.5 and our FirESmart scenarios of agroforestry and farmland. But what's more interesting to highlight here is the great difference in sizes with the real zones. Our core areas required almost 4 times more area to achieve these targets than the real zone, which is a little above 1,000 square kilometers, whereas our transition zone was almost 3 times smaller under all scenarios. This heavy difference in sizes leads to the similarity or the spatial overlap of the zones to be really low. But what we can see is that the transition zone of our results is the most similar to its corresponding real zone, whereas the buffer zone and core zones are much more or less similar to the real buffer and core areas. This highlights in part the need for the reserve to redesign its zoning to maintain its effectiveness for conservation in future years. And let's now move on to fire intensity. We calculated the mean fire intensity in each zone, and we can see that the buffer and core areas always had higher fire intensities, which is in part to be expected because they have more forests and shrubland land cover that are always expected to burn with higher intensity than other land covers such as agriculture or grassland that are more common under the transition zone. But what's important to highlight here is the clear and strong tendency of the business as usual scenario to have much higher intensities than all other scenarios, indicating a clear need to deviate from current management policy. Then for trade-offs, our use of management toning allowed us to avoid significant trade-offs that allowed us to achieve all targets. But what we did identify is mainly, I hope you can see my cursor. What you can see is a strong representation of agriculture under core areas, which was needed both for the small part of agriculture that we want is under the core zone, and also for habitat for the rare open habitat species that need to be protected under this area. Now let's move a bit to discussion. First of all, you can see in the map our results under each scenario. And the first thing we can highlight is the fact that the transition zones in brown are a bit more stable across scenarios. They do not change too much, mainly because these are areas comprised of agriculture. They are located in lower altitudes and close to urban settlements. So they are not expected to heavily change in future years, and thus can be allocated to the transition zone with high certainty. But this did not happen for the core and consequently the buffer areas that heavily change across scenarios, meaning that future management of the reserve will need to account for these landscape dynamics in forest and shrublands that will depend on future management policy. Then I want to highlight an important point of the discussion, that is that our assessment is based on quantitative targets for biodiversity and ecosystem services, and accounts for 3 global change drivers: climate change, land cover change, and wildfires. Whereas the real implementation of the zones was done in past years using already existing natural areas, and also have to deal with more complications like several policies, laws, stakeholders that make a real implementation of zoning much more difficult. But the take-home message I want to give you, what I want to highlight, is that the potential is there for the Meseta Ibérica to maintain a high level of supply and biodiversity conservation, but doing so will require to make 2 main changes. First of all, the reserve will need to reconsider its zonation, especially regarding the extent of conservation areas. And secondly, management policy needs to shift as soon as possible from current management, and could instead focus on both on either a climate smart or fire smart policy, since both can enhance the effectiveness of the reserve, although focusing on different aspects of landscape management. Here are a couple of data sources from other works under the FirESmart project. And that's it. Thank you very much. I just want to say that hopefully there will soon be a published paper on this work, so don't miss out on it. Here are a couple of places where you can have more information or reach me. Thank you very much.